Polynomial equation. This topic was introduced to you during your 7th grade mathematics. I assume you started learning polynomials by characterizing it through a number of terms. These are monomials, binomial, trinomial, and multinomial. And I also expect you ask yourself, where can I use polynomials and polynomial equations? Will it benefit me or can I use this concept in my future job? If these questions continues to bother you, then I suggest you should finish this video. Let us start this video lesson by recalling the difference between the terms polynomial expression, polynomial equation, and polynomial function. Polynomial expressions are mathematical terms with no relational symbols. So when we say polynomial expression, this could mean monomial, binomial, trinomial, or multinomial. Polynomial expressions in this way are described by identifying the number of terms. Secondly, polynomial equations. These are mathematical declaration being one of unconditionally true, conditionally true, or unconditionally false, involving expressions and the equal sign. When we refer to polynomial equation, this could mean linear equation, quadratic equation, cubic equation, and so on. And lastly, polynomial functions. Polynomial functions are mathematical machine that takes input and gives output values. Examples of this are linear function, quadratic function, cubic function, and the like. So let us answer the question, where can I use polynomials, polynomial equation, and polynomial functions? Have you wondered how do businessmen make big decisions for the profit of their company? Or have you become curious how weather forecaster and analysts make weather reports? Have you heard statisticians making prediction of population? Or doctors or researchers predicting the number of COVID cases given a span of time? Well, these questions are all answered by polynomial equations and functions. Polynomial equations and functions model real-life scenario. Learning to express real-life situations as mathematical functions models allows us seemingly complex ideas and actions to be broken down into smaller and simpler parts and analyzed. Indeed, polynomial equation and function is very fascinating to study, but due to its complexity, most of us are not interested to pursue studying its higher applications. However, effective learning of this complex analysis starts with a firm and clear understanding of basics. So for this video lesson, we will talk about fundamentals of polynomial equations. Particularly, for this lesson, we are going to identify polynomial equations. Secondly, we will write polynomial equation in standard form. And lastly, you shall be able to identify roots of polynomial equation. Let's continue this video lesson by defining polynomial equation. Polynomial equation is a special kind of algebraic equation where each term is a constant, a variable, or a product of constants and variables raised to a whole number exponents. Remember, the exponents of the variables should be whole number. That should consist the set 0, 1, 2, 3, 4, 5, 6, and so on. Secondly, it is defined as an equation of more than two algebraic terms, especially the sum of several terms that contain different powers of the same variables. And thirdly, polynomial equation is defined as a sub n multiplied by x raised to n added by a sub n minus 1 multiplied by x raised to n minus 1 plus a sub n minus 2 multiplied by x raised to n minus 2 plus and so on until a sub 1 multiplied by x added by a sub o or a sub 0 is equal to 0, where a sub n is not equal to 0, n is a positive integer, and the largest exponent n denotes the degree of the polynomial. Based on the set of definitions presented, let's identify which of the following is or polynomial equation or equations. Number 1, 14x is equal to 0. Number 2, x raised to 3/4 plus 3x raised to 1/4 plus 7 is equal to 0. Number 3, 4x raised to negative 100 plus 4x raised to 100 is equal to 0. Number 4, 1 over 5x squared is equal to 4. Number 5, 5x squared minus 4th root of 2x plus x is equal to 0. You can pause this video enabled for you to answer this at your own pace. Let's now have the answers. In the set of items, the only polynomial equation is equation number 1, while the rest of the equations are not polynomial equation. Let's find out why. In equation number 1, 14x is equal to 0, the variable x has an exponent of 1. Since 1 is a whole number, therefore, the equation is a polynomial equation. Number 2, the first term and the second term of this equation has an exponent of fractional exponent, 3/4 and 1/4. And we know 3/4 and 1/4 are not whole number. Therefore, this entire equation is not polynomial. Next, number 3, since in the first term, the variable x has negative exponent which is not a whole number, therefore, this entire equation is not polynomial because negative 100 is not a whole number. Number 4, 1 over 5x squared can be written as x raised to negative 2 over 5. And negative 2 is not a whole number exponent. Therefore, this equation is not polynomial equation as well. Lastly, number 5 is not polynomial equation because the second term, negative 4th root of 2x, can be written as negative quantity of 2x raised to 1/4. And 1/4 is not a whole number exponent. Since it has a fractional exponent, the entire equation is not polynomial equation. Were you able to identify correctly which of those equations represent polynomial equation? That's great. Let's now proceed to standard form of polynomial equation. When do we say that a polynomial equation is already arranged in its standard form? A polynomial equation is arranged in standard form when the terms are ordered from highest to lowest degree. For example, so this polynomial equation, negative 4x cubed minus 15x plus 6 plus 7x raised to 5 is equal to 0 is not yet arranged in standard form. These terms will now be arranged in descending order of degree. The term which has the highest degree is positive 7x raised to 5. The next term should be negative 4x cubed. And the term next to it is negative 15x. And the last term is positive 6. In that manner, we arrange the degree of each term in descending manner. 5, 3, 1, and 0. So we have now the standard form of polynomial equation as 7x raised to 5 minus 4x cubed minus 15x plus 6 is equal to 0. The first term in the standard form of polynomial equation, 7x raised to 5, is what we know as the leading term. And the coefficient of the leading term is what we know as the leading coefficient. And lastly, the degree of the leading term, which is 5, is what we know as the degree of the polynomial equation. Let's now try answering the following exercises. Write the following polynomial equation in standard form. Identify its degree, leading coefficient, and the constant term. Number 1, negative 11 plus x raised to 4 minus 3x squared is equal to 0. Number 2, 8x cubed plus x raised to 6 minus 6x raised to 4 plus 1 is equal to 0. Number 3, x multiplied by the quantity of 5x cubed plus 7 is equal to 0. And lastly, number 4, the quantity of x minus 3 multiplied by the square of x minus 2 is equal to 0. Again, you can pause this video and able for you to answer these at your own pace. Let's now have the answers. Number 1, the equation could be arranged in standard form as x raised to 4 minus 3x squared minus 11 is equal to 0, having the degree of 4, leading coefficient of 1, and constant term as negative 11. Number 2 is arranged in standard form as x raised to 6 minus 6x raised to 4 plus 8x cubed plus 1 is equal to 0, having the degree of 6, leading coefficient of 1, constant term of 1. The standard form of number 3 is 5x raised to 4 plus 7x is equal to 0. It has a degree of 4, a leading coefficient of 5, and a constant term of 0. Why? You need to distribute x to 5x cubed plus 7. That is x multiplied by 5x cubed is 5x raised to 4. X multiplied by 7 is positive 7x. That is the standard form of that polynomial equation. Number 4, a standard form of x cubed minus 7x squared plus 16x minus 12 is equal to 0, having the degree of 3, leading coefficient of 1, and the constant term of negative 12. Before writing this equation in its standard form, we need to multiply x minus 3 and the square of x minus 2. The square of x minus 2 is equal to x squared minus 4x plus 4. That's still to be multiplied by x minus 3. By distributive property, x times x squared is equal to x cubed. X times negative 4x is equal to negative 4x squared. X times positive 4 is equal to positive 4x. Negative 3 multiplied by x squared is equal to negative 3x squared. Negative 3 multiplied by negative 4x is equal to positive 12x. And negative 3 multiplied by 4 is equal to negative 12. Then, by combining like terms, the standard form will be x cubed minus 7x squared plus 16x minus 12 is equal to 0. Did you write all the polynomial equation in standard form correctly? If so, that's great. Let's now proceed 2. The solutions, roots of polynomial equation. Suppose we have a linear equation x plus 3 is equal to 0. What must be the value of x enable for this linear equation to be true? By using property of equality and solving for x must be negative 3. So that negative 3 plus 3 is equal to 0. And that statement, 0 is equal to 0, is true. This value of x, which makes the polynomial equation true, is what we called the solution or roots of polynomial equation. We have a theorem regarding polynomial equation, and that is, if a polynomial equation a sub n multiplied by x raised to n plus a sub n minus 1 multiplied by x raised to n minus 1 plus a sub n minus 2 multiplied by x raised to n minus 2 plus until a sub 1 multiplied by x plus a sub 0 is equal to 0 can be expressed as the product of n linear factors, then the polynomial equation has n roots or solutions. These roots or solutions can be real roots or imaginary roots. So how can we solve for the roots of polynomial equation? We can solve for the roots of polynomial equation by graphing, factoring, by using the press equation, synthetic division and remainder theorem, and lastly, the rational roots theorem. For this session, we will use the methods of graphing and factoring in solving the roots of polynomial equation. Aside from manually graphing the polynomial equation, you can utilize some graphing tools which will help you immediately graph polynomial equation. Some of the graphing tools include Automat, GeoGebra, and Desmos. Let us now solve for the roots of polynomial equation through graphical approach. Suppose we have graphed the polynomial equation x squared plus x minus 6 by expressing it as function of x in our graphing tool GeoGebra. We will find the x-intercepts, or at what point on x-axis does it intersect the graph, because it is stated that the left side of the equation must be 0. By highlighting, we can see that the x-intercepts are negative 3, 0 and 2, 0. If we're going to verify these values at the given equation, we can see that the x-intercepts are indeed roots of polynomial equation. When x is equal to negative 3, by substituting into the equation, negative 3 squared plus negative 3 minus 6 is equal to 0. That is 9 plus negative 3 minus 6 is equal to 0. Therefore, negative 3 satisfies the polynomial equation x squared plus x minus 6 is equal to 0. Then, negative 3 is a root of the polynomial equation. When x is equal to 2, we can see that 2 squared plus 2 minus 6 is equal to 0. That is 4 plus 2 minus 6. That is the same as 0. The polynomial equation is true as well when x is equal to 2. Therefore, the roots of this polynomial equation are negative 3 and 2. Let's proceed to the next example, having the graph of polynomial equation x cubed minus x squared minus 25x plus 25 is equal to 0. We can see that the graph intersects the x-axis 3 times. It implies that this equation must have 3 solutions or 3 roots. By zooming in, we can identify the x-intercepts as negative 5, 0, 1, 0, 5, 0. We can see that negative 5, 1, and 5 satisfies the equation. Therefore, these x-intercepts are indeed the roots of the polynomial equation. So we have now the conclusion that x-intercepts are the roots or solutions of polynomial equation. Another method you can use to solve for the roots is the method of factoring. We learned a lot of factoring techniques in your 8th grade mathematics. Some of these are factoring through GCF, the sum product pattern, grouping method, perfect square trinomial, and the difference of square patterns. So given the previous polynomial equation, x squared plus x minus 6 is equal to 0, this equation has factors of x plus 3 and x minus 2. By using zero product property, if one of the factors becomes 0, then the whole equation will be 0. So suppose we take the factor of x plus 3. We know that this factor x plus 3 will become 0 when x is equal to negative 3, because negative 3 plus 3 is equal to 0. So the factor x plus 3 will become 0 if x is negative 3, thereby making the whole equation 0, because any number multiplied by 0 will be equal to 0. Another root will be coming from the factor x minus 2. The factor x minus 2 becomes 0 when x is equal to 2, because 2 minus 2 is equal to 0. Therefore, this number multiplied by another, or 0 multiplied by another, will become 0. So the whole equation will become 0. Earlier, we solved the roots of the polynomial equation x cubed minus x squared minus 25x plus 25 is equal to 0 using graphical approach. Let us prove the same roots will be obtained through factoring method. X cubed minus x squared minus 25x plus 25 is equal to 0 has the factors of x plus 5, x minus 1, and x minus 5. So by using the zero product property, we know that the factor x plus 5 will become 0 when x is equal to negative 5, because negative 5 plus 5 is 0, while x minus 1 will become 0 when x is equal to 1. 1 minus 1 is equal to 0. And thirdly, the factor x minus 5 will be 0 when x is equal to 5, because 5 minus 5 will become 0. Therefore, we have the roots as negative 5, 1, and positive 5. By verification, we can see that when x is equal to negative 5, it is indeed 0 is equal to 0 when x is equal to negative 5 is substituted into the polynomial equation, the same way as when x is equal to 1. And lastly, when x is equal to 5. So we have now the roots of the polynomial equation x cubed minus x squared minus 25x plus 25 is equal to 0 as negative 5, positive 1, and positive 5. Example number 3. Suppose you are given the polynomial equation which is already in factored form. That is, quantity of 2x plus 1 squared multiplied by the quantity of x minus 2 cubed is equal to 0. This polynomial equation can be expressed and written as linear factors, such as 2x plus 1 times 2x plus 1 times x minus 2 times x minus 2 times x minus 2 is equal to 0. The factor 2x plus 1 will be 0 when x is equal to negative 1/2, while the factors x minus 2 will be 0 when x is equal to positive 2. Therefore, we have two distinct roots as negative 1/2 and 2, but negative 1/2 is used twice while positive 2 is used thrice. Therefore, this polynomial equation has the roots or the solutions as negative 1/2 with a multiplicity of 2 and 2 with a multiplicity of 3. Multiplicity refers to the number of occurrences of this root in the complete factorization of the polynomial by means of the fundamental theorem of algebra. That is, if a polynomial equation a sub n multiplied by x raised to n plus a sub n minus 1 multiplied by x raised to n minus 1 plus a sub n minus 2 multiplied by x raised to n minus 2 added by until a sub 1 multiplied by x plus a sub 0 is equal to 0 can be expressed as the product of n linear factors, then the polynomial equation has m roots or solutions. Since the polynomial equation is expressed as 5 linear factors, therefore this polynomial equation has to have 5 roots. These are negative 1/2, which is used twice, and positive 2, which is used thrice. And the number of roots of this polynomial equation represent the degree of the polynomial equation. Since the degree of the polynomial equation is obtained by identifying the degree of the leading term, we will just multiply the leading term of each factor to obtain the leading term. That is 2x times 2x times x times x times x. And that is 4x raised to 5. So suppose we have now the leading term 4x raised to 5. We can now identify the degree of the polynomial equation. And the degree of the polynomial equation should be 5. As you can notice, the degree of this polynomial equation is the same as the number of roots. Upon verification, we have now a clearer understanding of fundamental theorem of algebra as a polynomial function f of x of degree n, where n is greater than 0, has n complex solutions for the equation f of x is equal to 0, where complex solutions or roots are composed of real or imaginary roots. For example, we have the polynomial equation x plus 5 is equal to 0. Since the polynomial equation is in degree 1, we can expect that it will have one exact solution. Since polynomial equation number 2 is in degree 3, we can expect that it will have at most 3 solutions or roots. Well, lastly, in number 3, since it is in degree 4, we can expect that it will have at most 4 solutions or roots. To help you assess yourself whether you learned something from this video, let's try answering this activity. Identify the degree, roots, and the number of roots of the following polynomial equation. The given is already expressed in factored form. Number 1, x minus 2 multiplied by x plus 2 multiplied by x minus 4 is equal to 0. Number 2, x times the quantity of x minus 1 squared times x plus 2 is equal to 0. Number 3, the quantity of x minus 3 squared times the quantity of x minus 5 times the quantity of x plus 5 is equal to 0. Number 4, the quantity of 5x minus 3 multiplied by x minus 1 multiplied by the quantity of 3x plus 3 cubed is equal to 0. And lastly, number 5, x multiplied by the quantity of x minus 7 squared multiplied by 6x plus 5 multiplied by the quantity of 4x minus 3 raised to 4 is equal to 0. You can pause the video enabled for you to answer these at your own pace. Let's now have the answers. The answers are: number 1, it has a degree 3, the roots of 2, -2, 4, and the total number of roots is 3. Number 2, it has a degree 4, the roots are 0, 1 with multiplicity of 2, and -2. Total number of roots is 4. Number 3, it has a degree 4, the roots are 3 with multiplicity of 2, 5, and -5. The total number of roots is 4. Number 4, the degree is 5. The roots are 3/5, 1, -1/3 with multiplicity of 3. And the total number of roots is 5. And lastly, number 5, the degree is 8, with the roots of 0, 7 with multiplicity of 2, -5/6, 3/4 with multiplicity of 4. And the total number of roots is 8. Did you get all the answers correctly? If so, you did a great job. I hope you learned a lot from this video. Please don't forget to like, comment, share, and subscribe. This is Sir JC reminding you, math is easy when you perceive it positively.